done different form of study here and there. We have learned different things. So we are just some few hours to the examination. It's just a form of revision. Probably you can learn one or two things from it. I hope you are following me. So we'll just take it from the simple one and then we move on to harder one. We'll just start from the simplest and that from the spring. So we'll just take questions from past questions and then we solve. But the challenge now is that I don't have a hard copy past question. The past questions on my phone. So maybe someone will have to read the question for me. I hope you are all with me. Hello.
Yes, sir.
Okay, so the question was anyone who is reading the past question. Anyone with a question? Hello, can you hear me?
Yeah, let's go. Can you hear me?
Yes, yes.
Okay, the first question here, I think is question 5 from 2003, 2024 past question, which has to do with spring. So let me just
Yes.
read it out. For the fixed end system given in question 5, so
Okay.
there's a diagram actually.
Yes.
You can draw the spring. It has four nodes. Um, each having a at the end of the nodes is a fixed end. Four nodes. So that's elemental stiffness K1, K2, K3.
So I think I've
Then
got. So what are the values
so
given? K is what?
wait, there's a first P on node 3.
Now I've gotten the question. Can you see
Okay.
the board? Hello. Can you see the board? Look at the
Yeah.
diagram. We are dealing with spring first. Look at the diagram. We have a spring K, K and then we are given our K1 to be 200 Newton per meter, K2 200 Newton per meter square, K3 200 Newton per meter square, 1000. And we are asked to find number one, the global matrix. That should be the global stiffness matrix. Displacement of node 2 and 3. So reaction. So those are the
So I
I
can't
know
see the board very well. A bit blurry.
Sam coming.
Okay, okay. It's better now. Probably my network. It's
Is it
better
okay
now.
now?
Yes, sir.
Okay. Now, solution. One thing you have to know in this all these whether it's spring, whether it's beam, whether it's bar, whether it's trucks, just make sure that you know your equilibrium equation, which is K multiplied by your displacement equals to your force. Just know this equation. Once you know this, the other thing is just to how you can convert all your questions into something of this nature, and then you are done. That's just the thing. So the first one, we know our stiffness K. Our K, the formula is we have K for spring. K minus K, and what again? Minus K and K. Am I right? Am I
Um,
right?
Yeah, you are.
For our K1, we are given our K1 to be 200. Then just simply 200 here minus 200 here minus 200 here and 200 here. That's all. K1. That is K1. You come to K2, and then K1 is between node 1 and node 2. Don't forget that K1 between node 1 and node 2. You are supposed to apply that one. Then we come to K2, K2 between node 2 and node 3. Then you get to K. Our K2 is given as 400. So you have here 400 minus 400 minus 400, then 400. You are just applying the formula here for all this one. You are just applying the formula that is here, and that's all. Then you come to your K3 given as 200. Then you have this one to be 200 minus 200 minus 200, then 200. Then remember that K3 is between node 3 and node 4. So that means that this one is 1 and 2, this one is 2 and 3, while this one is 3 and 4. So you cannot have it this way. Our displacements along x will be u, y along y will be v. So please, if you are writing, you have to be writing fast because I need to be cleaning the board so that I can have space to be writing. So if you are writing, please just make it faster. Then our K1, since it's between 1 and 2, you have U1 here, V1. So you don't even need. So we want to get the global matrix now. The global matrix means that combine these three. We want to combine them together. Combine 1, 2, 3, combine them together. So how will you do that? You are going to have this. If this one is U1, V1, U1, V1, U2, V2, U2, V2, U3, V3, U3, V3. Do you see what I wrote here? U1, V1, U2, U1. Do you see all those ones?
Yes. Well, why can't you use U1, U1, U2, U3, U2, U3, so that you can follow? I don't know.
Is the okay if you want it that way. U2, then now combining them together now, you have U1, U1 that was 200.
Yes,
U1,
sir.
U1, 200. Are we together, please?
Yes, sir.
U1, U1, 200. U1, U2, U3, U4. So node 1 is between node 1 and 2. That's why you're having U1, U2, U1, U2. Then node K2 is between 2 and 3. You're having U3, U2, U3, U2, U3. Then K3 is between node 3 and 4. You're having U3, U4, U3, U4. So combining them together, U1, U1, you have to write this one, U1, U2, U3, U4, then U1, U2, U3, U4. U1, U1, 200. Then U2, U1, you come to your stiffness matrix here. U2, U1, you have minus 200. Then you come here, U3, U1. You don't have anything like U3, U1 here. Nothing like U3, U1. What you have is U3, U3. So, or U2, U3. There's nothing like U3, U1. So it is 0. You come here, U4, U1. Nothing like U4. All you have is U4, U4, and U4, U3. So this you don't have U4, U1, then you put a 0. We come to the second row here. U1, the U1, U2. You come here, U1, U2, minus 200. Then you come here, U2, U2. You have U2, U2. That is 200. Then you come to U3, U2. Do we have U3, U2? U3, U2. And that is minus 400. Are we following, please? Hello, are you following?
We have to you to you to.
U2, U2, U2. Okay, that is there. That's U2, U2. That's 400. No, U2, 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 200 here. Then U2, U2, 200. So 200 plus 400 will be what? 600. Sorry for that. We're having U2 and U2 is 200 here. We're having U2 and U2 is 400 here. So the addition of this one and this one gives me 600. Do we get that, please? Do we get that?
Yes, yes, we do. Yes, we get it.
Yes, sir.
Now, now U3, U2, U3, U2, and also here U3. Okay, not the U3. So you have U3, U2, which is minus 400. Then we now have U4, U2. This is which we don't have U4, U2, so we put a 0. Or is there U for U2 there? There's no U for U2. So it is 0. So we come to the next one. U1, U3. Nothing like U1, U3. So this is 0. U2, U3. U2, U3. Minus 400 here. U2, U3. We have minus 400. I think that's it. Then we come to U3, U3, U3. U3, U3. 400 here. Then U3, U3. 200 here. Making 600. And then U4, U3. U4, U3. That's minus 200. Are you following, please? Then we have U1, U4. No U1, U4 is 0. Then U2, U4. No U2, U4 is 0. Then U3, U4. U3, U4 minus 200. Then U4, U4. U4, U4, which is 200. So that's the global stiffness matrix. And that's the solution for question 1. Question 1 has been solved. The global stiffness matrix. Then the other one says that the displacement of node 2 and 3. Having gotten your K, the global stiffness matrix, apply the formula K times displacement equals to F. K times displacement equals to F. And then you know your K to be this. Our K is 200 minus 200 is 0, 0. I'm going to example 2 now. I want to find the displacement now. Then minus 200, 600 minus 400 is 0. Then is 0 minus 400, 600 minus 200. Then you have is 0 minus 200 and also 200. This is your K. Then your U, your displacement, you are having, our U is from 1 to 4. That is the displacement in node 1, node 2, node 3, and node 4. So you're not going to have U1, U2, U3, then U4 equals to my F2. I have my forcing spring 1, spring 2, spring 3, spring 4. But now I'm going to put it this way. F1, F2, F3, F4. Now, having done this, the next is now to apply boundary conditions. I hope we are still following. Are we still following?
Yes, yes, yes.
Please, we cannot see the board. Like, we cannot see what we've been writing since.
Can't you see the board now?
I can see the board, but the board is not full. What is writing at the other edges is not clear.
This side.
Yes, that side is not showing.
On your own side.
Maybe you zoomed in your screen. You've zoomed in your screen.
Question, you can just come attention. I can ask a question. Just tomorrow is the exam. Any question you might be having, just clear your mind on any question so that we don't get this mixed up. From the equation is not to apply our boundary. What the boundary condition is, you look at what you are given, whether it's spring or anything, and then the question have told us that it has a fixed end. The question said it has a fixed end, and for a fixed end we know that moment is 0, displacement in both directions x and y, they are also 0. Now that means that displacement in node 1 and node 4, they will be 0. That's why we have u1 will be equals to u4 will be equals to a 0, because they are fixed end. They are fixed end. So we are going to have displacement in node 2 and node 3, and that is why the question says find displacement of node 2 and 3, because this is where we are going to have displacement, since node 1 and node 4 are fixed. Their displacements are 0. Now we are going to apply that condition into this equation now, and remember we are giving our p to be 1000. Position where the p was included in node 3. The question put it this way, p in node 3. So we are going to apply that one now. So I want to rub this off. Can I rub this off?
Sir.
Can I rub this one off? Now, applying the boundary condition, we are going to have 200 minus 200 is 0, minus 200, 600, minus 400 is 0. Then I have minus 400, 600, sorry, is 0, minus 400, 600, then minus 200, then is 0, minus 200, then 200. And then your displacement now, here is 0. I have my U2, I have my U3, and my U4 is also what? Is 0. Do we get it like that? Equals to my F. I have my F1,
Yes, sir.
my F2, my F3 is given as P. My F3 is given as P and given as 1000. So I have 1000 here. And I have my F4. Now looking at this equation now, since this one is 0 and this one is 0, we are going to do something here. The first one is 0. That means that all the stated that the first one is 0, all this row will equals to a 0, and this column here equals to a 0. The first row and the first column is 0. Now, since the last one also is 0, the last column, the last row, and the last column is also what? Is 0. They cancel out. Then we are left with this one, minus 400, minus 400, then 600. Then you put this in your bracket, equals to, we are left with U2 and U3, equals to, we are left with F2 and what? 1000. Are we following? Then we take our F2, taking F2 to be 0. F2 to be 0, we are going to have 600 minus 400 minus 400, 600. Then you have U2, U3. Then you have 0 and what? Hope we get it. Then just use your normal multiplication of matrix. How you multiply matrices. That's the next thing now. Now, to another matrix, it goes like this. Your row will multiply the row will multiply the column. That's matrix. row multiply column. So how do we apply that one to get this one now? That is 600 times U2 will give me 600 U2 minus 400 times U3 will give me minus 400 U3 equals to the first one, because that's the first row, equals to 0. Then the second row minus 400 times
Hello,
U2.
engineer.
Yes.
Hello, sorry, please. Why do we take the F2 to be 0? What conditions are applicable to that?
Now F2 wasn't given, the body was not given, and then for you to solve, you have to make it like there's no force in that place to be 0, since we are not given. We are given F3 to be 1000. You get it? So we are asking for the F2. You take it that there is no force in that spring there. That's as soon as it's equals to 0.
Sorry, sir. Can't our answer be in the function of F2?
So why do you want to live in function of F2? You are asked to find a displacement.
I think most questions that are solved in the material, they did not assume 0 for the first. If I'm right, I don't know.
Here, we are taking it as F because we are going to get a value for it. Even though if you look at the question, the material the one gave us, such a question like this is there, and it's taken as F2, so we will now get a displacement for O2 and O3.
Okay, sir.
So we get 600 times U2, 600 U2 minus 400 times 3, this then equals to 0. Then we have minus 400 U2, 600 times U3, 600 U3 equals 1000. Do we get that? Then you can solve this one simultaneously. You can say this one times 2 times 3. That's to make U2 to be equal. Then 2 times 600, we have 12 U2 minus 2 times 400, 800 U3 equals to 0. I hope you understand this one. Just simultaneous equation. How to solve simultaneous equation? Elimination method. So 3 times 400, we have minus 12 U2 minus 3 times 600 plus 18 U3 equals to what? 3000. Then U2 and U2 can cancel out since they are the same and opposite sign. If this as 800 minus 800 plus 1000 U3, this one will give me 1000 U3 equals to 0 plus 3000 equals to 3000. So divide both sides by 1000, 1000, cancel, our U3 equals to 3 mm. That's, we have gotten U3 like that. Are we following? Do we understand to this place? Hello?
Yes.
Yes. It's very clear.
Now, just to find your U2, substitute U3 into any of the equation, either equation 1 or equation 2. Then you have, let's take equation 1. I call this one equation 1. I call this one equation 2. So my equation 1 is 600 U2 minus 400 U3 equals 0. I've gotten U3 to be 3. I want to put it here. Then 600 U2 minus 400 brackets 3 equals 0. So I have 600 U2 equals to 1200. Divide both sides by and U2 equals to 2 mm. So those are the displacements at node 2 and node 3, and that's very, very simple. That's simple. So the third question says you should find the reaction at the two ends. The reactions at the two ends. So what will you do? Reactions at the two ends. The third question now, reactions. The reactions at the two ends. So how will you do that? You come back to your table here, the equation you have formed. That your K times U equals to F. This equation here, the matrices here, you come to this place again. Remember that we have gotten our U2 and U3 now, so it's easy now. Now, your reaction is F1 and F4. Those are two reactions at the two ends, F1 and F4. So, we use some multiplication method, just the way you multiply to get this one. So, what do you do? Remember that if I want to get my F1 will be equals to the multiplication of this first two and the column. The first two and the column will give me F1. Now let's start with 100 give me 200 times U2, I have 200 U2. A 0 times U3 will give me a 0. A 0 times a 0 will give me what? A 0. That means that my F1 equals to minus 200 U2. And then minus 200 bracket. What is my U2?
Please,
My
can you do that again?
U2. Are we following, please?
No, do that again. The F1, please.
Okay, look at it. Multiplication F1. 200. We are going like this. Row times column. Row times column. 200 times is 0 gives me a 0. Do you agree with that?
Yes.
I need your please.
Yes.
Do you agree? 200 times this is 0 here gives me a 0. Yes or no?
Yes.
Yeah? Minus 200 times U2 gives me minus 200 U2. And I come to this one now. 0 times 23 will give me a 0. Then this is 0 times is 0 here will also give me a 0. So I'm not going to F equals to minus 100 U2. And we know that our U2 is 2 mm. So that becomes minus 200 times 2, which give me minus 400 Newton. Do we get that? Do you understand, please? Let's respond so that we know that
Person kindly mute.
We understand.
We understand, sir.
okay, now F4. So F4, now what F4 gives me now, you come to the F4 will be for the last row. F4 will be for the last row. F will be for the last row since this is the last the last value there. So F will be for the last row. That is 0 times 0 here is 0 plus 0 times U2 is 0 plus minus 200 times U3. That minus 200 U3. Then 200 times is 0 will give me a 0. So I'm left with minus 200 U3, which is minus 200 bracket 3. U3 is 3. So I now have minus 600 Newton. So with that, we have solved the question. Any question, please?